Well, yesterday I discussed about hypothesis testing and its objective in statistics. And I told you that in hypothesis testing, actually, we study the validity of the null hypothesis. Every null hypothesis is associated with one alternative hypothesis. And I also said that how to draw conclusion on the basis of the test result. Now, in hypothesis testing, many more things are there which needs to be discussed. Okay, not everything has been discussed so far. So gradually we'll get to see what are these things, and we will try to learn them through examples. Now, to start with, first of all, a very brief prerequisite that I have to make over here, because if some of the students were absent yesterday, they would be able to know what were the matter of study in my last class. I said null hypothesis is the hypothesis of hypothesis of no difference. This is called the hypothesis of no difference. And alternative hypothesis is the complementary to null hypothesis. Null hypothesis is denoted by H0. It is a statement about the situation. Alternative hypothesis, on the other hand, is denoted by H1. Okay. And the test that we performed in our last class was a special type of test where we used this type of formula, x minus mu by sigma. And we know that it is the standard normal variate. It is the formula that we used in our previous problem. In this formula, we set up the mean to be n into p, and we set sigma to be root over np q. And we also know that n is the number of observation of the system and p is the probability of success. So actually the formula connects binomial situation to normal. It is called binomial approximation to normal, where q is equal to 1 minus p. And I also told you how to draw the conclusion. I said that if the value of mod z is greater than 3, you are supposed to reject null hypothesis always. Always. Okay. So these are the 3 things that I discussed in my previous class. Now, what I didn't discuss is the following. The first thing that you have to know, that the formula that I used in the previous session, that is the formula of this type, that is, let me write it in explicit way. It is x minus np by root over npq. Okay, this particular formula can also be written in different manner. What we can do is that we can divide the numerator and denominator by the sample size or the number of observation, and we can get a different form of this formula. So we can write it as x by n minus p. Okay, and this would be p q by n under the square root sign. How? Because this n is outside the square root, and if I put it inside, we have to make it square. So one n will cancel another n from this n squared, and we'll get pq by n. This is another version of the formula. Okay, either sometimes we use this or sometimes we use that, depending upon the situation. But ultimately, we are going to get the same result. This is the first part that I want to tell you. Second part is that, if you can recall, in the last class, we discussed about a problem which was having, the problem of the last class was having $9,000 tosses. 9,000 tosses of a particular die, and we discussed whether the die is how to find out that the die is biased or unbiased. Now you try to look at the figure 9,000. So the experiment, hypothetically or practically or whatever, or it can be a thought experiment or in mind also, whatever way you do the experiment, this particular observation is too large. So it's n,000. Now in hypothesis testing, here is the important question that we need to find out. First of all, I gave you some steps of the hypothesis testing. I told you that first of all, if you get a problem, you have to design the null hypothesis and the alternative hypothesis. And you have to, in step number 2, you have to select an appropriate formula. In step number 2, you are going to select an appropriate formula. The question is how to select that formula. That has not been discussed. How to select that formula. Because in hypothesis testing, probably you are expecting there are many more formulae. The answer is yes, many formulas are there. But in this particular problem, we have used this particular formula because of a special reason. The first reason of this is that we look at the size of the sample. We look at the size of the observation. If the size of the observation is large, we use large sample test. If the size of the sample is small, we use small sample test. So there are actually two categories. One category is if the size of the sample, which is denoted by n, is large, we basically use large sample test. And if the size of the sample is small, we use small sample test. And none of the students present over here will ever think this particular figure 9,000 to be a small figure. Everybody will say that, yeah, if I ask them, everybody will say that it is a large figure. Everybody knows it pretty well. But the question is, what is the benchmark? What is the benchmark of such a figure? I mean, there must be something above which we'll say that we'll call it large sample and below which we call it a small sample. Now the benchmark is not too large. The benchmark is pretty small, and you will be amazed to see, and you will be thinking why this pretty small figure has been considered as a benchmark, but it has a kind of statistical history. I'm not going into the details of that. So the benchmark is the following. A sample is large. A sample is large if n is greater than 30. A pretty small figure. If n is greater than 30, this is a large sample. A sample is small if n is less than 30. Okay, so if n is large, that means n is greater than 30, n is small if n is less than 30, and now you can correlate the two things. You are sure about that here n is pretty large, much larger than 30. N is much larger than 30. Okay, and therefore it is a large sample, and the test that we have used over here is a large sample test. Okay, so the test used in the last problem was large sample test. Okay. Now, large sample test, in large sample test, the formula, the basic formula, the basic feature formula that we used is the following: Z equal to X minus mu by sigma. That is the formula that we used. Sigma took a special type, special form, and mu took a special form. Here it is NP and NPQ. Mu is NP and sigma is root over NPQ. Depending upon the situation, the structure of the value of mu, the form of mu and sigma will keep on changing. But this formula in large sample test will remain fixed. We will not change the formula. We'll keep it fixed, but we'll only change depending upon the situation. We'll only change the shape of mu and the shape of sigma. Okay. Now let us analyze the situation a little bit further. Okay. This particular test that I used in the last class, in the previous class, was a special type of test. It is called test of significance of single proportion. Test of significance of single proportion. This is the test that I have used. We have to understand what is the meaning of this test of significance of single proportion. Let us dissect the words term by term, and let us try to understand what does this mean and why it is called the test that I used in the previous class, why it is called the test of significance of single proportion. First of all, let's talk about test of significance. Test of significance is synonymously known as the hypothesis testing. You have made some kind of assumptions regarding some kind of parameters, okay, about the population. You have said the dye is unbiased, and you are talking about its probability of success. You are declaring that it is 1/3, 1/3. Okay, and therefore it is a kind of hypothesis that you have made. Now, test of significance means testing of your hypothesis and to judge how much significance your assumption has. Can it be accepted for statistical purpose? So that is called test of significance. And you will get this term, test of significance, in every test. We'll say test of significance of single proportion, we'll say test of significance of that, we'll say test of significance of this, and so on. Test of significance is a common term. So test of significance means testing of your null hypothesis, which is a hypothesis of no difference, to check whether the value retained by it is a significant value or not, which can be accepted. Now the second part, test of significance of single proportion. Now, what is the parameter that we actually tested in our previous example? The parameter was, the null hypothesis was H0, P is equal to 1/3. Now you know that the situation we dealt with, a kind of situation which can be visualized from binomial point of view. And in binomial, there are two types of parameters. One is n and another is p. Now, we tested the value of the parameter p in this particular case. Now, what is p? P is probability of success. Probability of success is also known as the proportion of successes. Therefore, we actually tested the significant value of the proportion. And therefore, it is called test of significance of proportion. Okay, now this part is understood. Now, what about a single? What is the meaning of the word single? Now you see that we discussed about 9,000 observations. 9,000 observations that we made. 9,000 observations we made by choosing situations from the population. And population is actually dice throwing as many times as you can. Okay, to get a fair result, you never know how many times you must repeat your experiment. But this observation is definitely infinity. Out of that observation, out of these observations, we have selected a sample of size 9,000. Okay, so my population on which I actually worked on, that population was only having the population under consideration was only one, because we selected the 9,000 observation from a population of dice throwing. Okay, so population involved in case was only one population involved from which we selected our sample, and therefore this word is there. It is called single proportion. It means testing of the hypothesis of no difference, testing of the hypothesis of no difference, and to judge whether its value is significant and the value has been obtained. The value of the parameter has been obtained from a single population. So therefore, it is called the test of significance of single proportion. And in test of significance of single proportion, we'll always be using this particular formula. Always remember this quantity, and this particular formula, according to its shape, it follows normal distribution with mean 0 and variance 1. Or you can use this formula also. So this is the formula this is the first formula of hypothesis testing that we'll be using for this type of large sample test. Okay, this is the first formula, and this is case number 1. This is case number 1. Okay, remember this always. Now, let's proceed with another problem. Okay. So let me select a problem from the book. Question: in a sample of 1,000 people, in Maharashtra, 540 are rice eaters and the rest are wheat eaters. Can we assume that both rice and wheat are equally popular in this state, and here is a new term has been introduced in the problem, in this state at 1% level of significance. That term has not been used in the previous problem. This is a new term that has been introduced over here. Okay. Now, first of all, we'll try to analyze the situation. Now, you remember that in every problem in hypothesis testing, there is a basic objective. Now, a problem has been given in front of you. This problem has its own base because of some object keeping some objective in mind, data has been considered. Data of people in Maharashtra being rice eaters or wheat eaters has been considered. Maybe if it is found that the rice eaters and wheat eaters are actually the proportion differ, the government is going to introduce some sort of planning, some sort of changes they are going to make in the state of Maharashtra. And they will, if there are more rice eaters, maybe the export of rice to Maharashtra will increase from Punjab. Or if it is found that the proportions are same, then not excess of rice will be sent to Maharashtra. Equal amount of rice and wheat will be sent to Maharashtra for its population's consumption. So it is actually distribution of food items to various states of our country. This is the basic objective of the problem. Now, if someone claims that in Maharashtra, he has taken a sample of 1,000 and he's saying that he's declaring, the experimenter is declaring that rice eating people and wheat eating people proportion are same, then this is not that we are going to believe at the first look. We are going to test it, because maybe he has falsified the data, or maybe it is only this is happening, this proportion is equal only because of this 1,000 people. If I repeat the experiment, maybe this proportion will no longer be equal. Who knows? Who knows? So therefore this needs to be checked. So first of all, in the solution here, now I'm going to, yesterday I wrote step 1, 2, 3, 4. Now here also I'm going to write the step. Now steps will increase. First of all, identify whether the sample is a large sample or not. This is the first step. I didn't talk about it in the previous class. Intentionally, identify whether it is a large sample or not. Now, let us make the identification. Here it is a large sample because here the figure is 1,000. So number of observation is actually 1,000, which is n, and which is much larger than 30, and therefore it is a large sample. Now, it is given that in this particular sample, it has been found that 540 are rice eating people, and the rest are wheat eating people. Okay, and we are going to test whether both rice and wheat are equally popular in the state or not. Now, here comes our step number 2. In step number 2, we will set our null hypothesis. Okay, in the previous class, this particular step was in our current step 2 was actually step 1, but that was a thing where I actually not analyzed the situation of it's being large or small. I didn't introduce that part, and therefore that was. But now, if I ask you to do the previous problem, you have to go for step number 1 as the identification. Okay, so we will set our null hypothesis first of all. Null hypothesis. Once the null hypothesis is set, automatically the alternative hypothesis will also be set because they come together. So we are going to set the null hypothesis. So 80. The question is, what am I going to write over here? First of all, let's make the statement. Let's make the statement literally. So my statement in literal way is the following: rice and wheat are equally popular. This is the literal statement. And in alternative hypothesis, we will write rice and wheat are not equally popular. Now, Now, this rice and wheat are equally popular, and the statement that the rice and wheat are not equally popular, that literal statement will do no good actually, because we actually want a concrete mathematical statement. So we have to design our null hypothesis in a mathematical way, first of all. So what is the way out? We have to put a value to the parameter. What is the parameter? Proportion of capital P is the proportion of rice eating people in this sample. Now, since the sample size is 1000 and the rice eating people number is given to 540, obviously 1000 minus 540 will give you the number of wheat eating people. So if you want to concentrate on the proportion of wheat eating people, then also you can do. There are two ways to find out that parameter. Capital P is actually the proportion of rice eating people, and here this is called the population proportion. Actually, population proportion that I am writing here is capital P. It is called the population proportion. Now we have to when we actually hypothesize something, we first of all hypothesize not on the basis of the sample. We hypothesize on the basis of the population. In the previous problem, we said that the die is unbiased. Now, when we say that the die is unbiased, actually it means that it doesn't mean that, yeah, if you do the experiment 9,000 times, you're going to get this either 3 or 4 this many times. No, it is not that. When we talk about something in null hypothesis, we talk about the population. Actually, we are studying the population. We're not studying the sample. We are studying the population with the help of the sample. So whenever we say the die is unbiased, it means that as many times as you throw the die, okay, and you keep on throwing the die, the number of getting 3 or 4, the probability of getting 3 or 4 is this 1/3. Here also, when I am considering the proportion of rice eating people, now it is said that the proportion of rice eating people and proportion of wheat eating people are similar, same, equal. So capital P is the null hypothesis that I am going to make is not about the sample proportion. A null hypothesis will be based upon the population proportion. So here I am going to write the statement on the basis of the population. So I am saying in Maharashtra, the proportion of rice and wheat eating people are equal. So therefore probability is half. 50% of the population eats rice, 50% of the population eats wheat. Okay, so they are equally popular. So this is my population parameter. Capital P is actually my population parameter. Okay. And consequently, in alternative hypothesis, we will write P not equals to half. Okay. Now, before I proceed to the problem, I have to talk about something which hasn't been discussed in the previous class. In hypothesis testing, there are actually 2 types of test. In every hypothesis testing, there are actually 2 types of test. One is called two-tailed test, and another is called one-tailed test. You will gradually understand the meaning of these two, but briefly speaking, two-tailed test means if you find in null and alternative hypothesis, if you find the combination of the symbol, null hypothesis is going to contain a symbol like this, equality. In alternative hypothesis, you are not sure about if it is not equal, then whether it is less or whether it is greater, because there are 2 possibilities. Whenever I say that our variable x is not equal to 2, that means I'm sure that it is not 2, but I'm not sure whether it is less than 2 or greater than 2. So as if the 2 sides are open. Either it is less than 2 or it is greater than 2. So 2 sides are open. So it is called two-tailed test. However, in one-tailed test, you are going to get a combination like this. So in one-tailed test, if I consider in null hypothesis the equality sign, in alternative hypothesis we may consider the greater than sign. This combination is one type of two-tailed test. If someone considered in null hypothesis, someone considers uh, equality sign like this, and in alternative hypothesis he considers the less than symbol, then it is also a kind of two-tailed test. Okay, so remember this particular thing. Now here in this particular problem, I'm considering that the null hypothesis is the proportion of rice eating people and wheat eating people, they are equally popular, they are equal, and alternate against the alternative hypothesis that they are not equal. Now, if they are not equal, I am not sure, and it is not mentioned, it is not clear from the question whether proportion of rice eating people is more than wheat eating people, or proportion of wheat eating people is more than rice eating people. So this test is actually called a two-tailed test. In the previous class also, we discussed about the two-tailed test. Okay, just look at the problem, look at the structure of the null and alternative hypothesis in the dice problem. You'll find it that this problem is also a two-tailed test problem. Then what we do actually in step number 2, we actually find out a suitable formula. In step number 2, we actually found out a suitable formula to deal with the situation. Now here in step number 3, that will become a step number 3. Our suitable formula will be as follows. So we will write this statement under the assumption that null hypothesis is true. We write it simply as under H naught. It means under H naught means under the assumption that the null hypothesis is true. And you know here small n is present, capital P is present. So in this particular case, we are going to use the formula which use the large sample test which was used for the dice problem. So we'll be using this formula once again. X minus NP root over NPQ. Okay. And question is, what is X? Now your X is the random variable which gives you, your X is the random variable giving you the number of rice eaters. As I told you that you can also work with wheat eaters because the number of wheat eaters are actually known from this particular problem. Sometimes it is known, here it is known, but sometimes it may be unknown. But here you can work with both of them. Either you work with the rice eating people number or you work with the wheat eating people number. So X is the random variable giving you the number of rice eating people over here. We are going to put the values. The number of rice eating people is 540. Okay, out of 1000. Sample size n is 1000. And probability capital P is the population probability. So it is half. And in the denominator, you are going to substitute these things once again. So it would be 1000. This would be half. And you know that capital Q is equal to 1 minus capital P. So that would be also equal to half. Now someone please quickly do the calculation and tell me what value is coming. Tell me what value of Z you are getting. Just don't take too much time. You can write in the chat box. Quickly, what value you are getting for this? I think that you are not sitting with your copies. My calculator is a pathetic condition. Oh, you have written 2.5 to 98. Yeah, exactly. 2.5 to 98. Now, Aditi Tiwari and Suman Rakshit, I'm going to tell you that Aditi is maintaining the thing that I once told all of you. Always keep 4 digits after decimal point. It is a good practice. Suman has actually rounded it off at the 3rd place. Quite okay. And the other student, he has rounded it off in the 2nd place, which is not actually not good. But here that will not affect our, this is not going to affect our conclusion. So don't have to worry about it. We can use any of these 4 values, but I will prefer the retaining of 4 digits. At least 4 digits is a good practice. So we'll write the value to be 2.5298. Okay, now it is Z is 2.5298. Now here comes the way of drawing the conclusion. So how to draw the conclusion, that is the important part. In the last class I talked about drawing the conclusion in the following manner. Conclusion, the first step of the conclusion's first step, we will write it as step A, is if mod Z is greater than 3, 80 is always rejected, which is not happening over here. Step number B, if mod Z is less than or equal to 3, 80 is accepted temporarily and a suitable level of significance is chosen. There are 2 types of level of significance. One is 5% level of significance. Another is 1% level of significance. 2 level of significance that we are going to consider over here. One is 5% level of significance, another is 1% level of significance. I'm afraid I will not be able to complete the discussion in this particular session, so we'll carry it forward to the next session. So I'm going to talk about, make sure that you have copied this statement in your notebook. Okay, and we'll start from here.